I'll just give you a quick background about myself. I think since we have already seen that in the registration page, but I just wanted to quickly run through about my bio. I'm Vinod Boga. I'm currently working as a lead data engineer at Collinson Group. I have completed my Bachelor of Engineering in Computers from Mumbai University, from Shan Anka Kutch Engineering College. Overall, I have 15 years of experience in the field of data predominantly. Got to work on various facets like data warehouse, data mart, data lake, big data technologies, and cloud infrastructure building. During this journey, I got an opportunity to work on various tools and technologies, right from Python, SQL to the big data suite of things in all the Apache NiFi, Hive, Atlas, and Alteryx. While these technical skills are available with me, I was able to work on these domains like telecom, DTH, insurance, loyalty, and FMCG, airline, and hospitality. In today's session, we'll be focusing more on a bit of practical based. I'll try to give as much information as possible, which are more important as well. But since we only have 1 hour of time, I'll be sharing a lot of references, documentations with you guys at the end of the session, where you guys can go through those documentation to have a bit more in-depth knowledge. But the session that we're going to have it today will be focusing more on the important points on NiFi. As a data engineer, there are three major aspects that we need to focus. First is where you should be able to build infrastructure for your application or a software that you want to work on. Secondly, once you build your infrastructure and deploy that, you should be able to provide your production support and troubleshoot all your issues which are ongoing. And thirdly, all the development work that can happen on that software, you should be capable enough to do that. So these are the three major areas that as a data engineer we normally focus. Otherwise, as a developer, you will be focusing more on the third side of things, which is only the development of the workflows. But as a data engineer, we'll be focusing on all these three facets, right? From your infrastructure build, production support, and troubleshooting, and your design of the application as well. Okay, so that would be the motive for me to share the knowledge on these three aspects. And as we go along, I'll show you uh, uh, the application live, how we can build, how we can use all the necessary components of it, and we will see all this is in today's uh, session actually. On the agenda side of things, I'll try to give you a short overview on Apache NiFi. Then where does it fit into the entire data ecosystem? Its architecture and the major components, the core components of NiFi, the features of NiFi, and a quick run through of the application and its component, how we can use, where does it reside, and so on and so forth. We'll also do the installation of Apache NiFi on our local and see how it can be done, and an architecture diagram of Apache NiFi from an industry standpoint. And if time permits, I will also show you some demo of building it in AWS Cloud. And then I'm going to take up some of the Q&A sessions of your side as well. So I will take up that. To start off with, on the overview of Apache NiFi, the NiFi stands for Niagara Files software, which was first built by US from National Security Agency. And it was then handed over to the Apache Foundation, where Apache NiFi was later on came into the Hortonworks distribution setup. Currently, Hortonworks distribution setup has been taken over by Cloudera. Hence, I think it's kind of a no more open, so I would say a free version. But since we have the Docker files available on Apache NiFi, we should be able to build that on our local, and at the same time, we can use it from an industry standpoint as well. So what we're going to see today is using the Docker image of Apache NiFi, and we're going to build that on our local. And that's how we're going to look into that. Now, there are two approaches on NiFi side. You can install that on a standalone machine, or you can build your NiFi as a cluster as well. But what we're going to focus today would be more on your standalone machine, how we can deploy that, how we can run our application, and so on. Okay. Uh, to start off with, Nifi is an open source software. And it has given multiple names to it. People call it as data logistic platform. We can call it as a data orchestration platform. We can call it as a data ingestion platform. You can name it as an ETL tool as well. But the major aspect of having Nifi is to have the automation movements of data between its separate systems. When I say separate system means systems which are not in common. You can have multiple systems which are in different shape and size. You can connect to those systems and then bring that data back into the destination of your own choice. So that's the reason Apache Nifi has its more advantage compared to other ETL tools or orchestration tools which we have. It is very easy to use, powerful, and it's a web-based user interface application where there is no coding required at all at the moment. A lot of people will feel that, do we need any coding requirement? But to work on Nifi, it's a GUI based and we can drag and drop and create our flow. So that is where the ease of use on Nifi comes into the picture. But at the same time, there are some nitty-gritties of information that we need to look into. And how can we build, how can we mitigate certain issues while it can come. Okay, so that we're going to look into it. It's a data source agnostic, which means you can connect to any source system which can generate your data, and data of your interest. You can plug into those systems and bring the data into the destination of your own choice. You can push into Hive, HBase, H2 database, and so on and so forth. One of the biggest advantage of Nifi is gives you the real-time scenario to update your workflows. Normally what happens is when you develop a pipeline in say ETL tool or any of the ETL processes, whenever you deploy and when you start your applications, you can only see some errors and it stops in between, and all of a sudden you need to go back, look at that application and then start it all over again. But with Nifi, it gives you a real-time feel. You can modify things on the go. You can stop your pipeline in between, rectify certain things, and then start your process from there on. That is where Apache Nifi comes in very handy in terms of updating your workflows in a real time. We're going to see that as well as part of our practice today. It is very highly configurable and modifiable. As I said, because of its real-time nature, you can configure and modify on the fly at runtime as well. One of the major aspect of Nifi is the flow file. Now, flow file sits at the heart of Nifi. It's as good as, say, when you play a game of football. Without the ball, without the football, you can't play the game. At the same time, in Nifi, without the flow file, there is nothing inside the Apache Nifi. So everything that we're going to see today in Apache Nifi will be based around the concepts of flow file. So a flow file is nothing but a packet of information which travels from your source to destination. Take an example that at a source you have 1 lakh records. You break that into a chunk of smaller size of say 5,000 records. So that flow file gets split into that 5,000 records and traverses from source to destination. And that is how the flow file comes into the consideration. Nifi doesn't take into consideration all the records at one go. The best practice of working with Nifi is to break your big chunk of information into smaller packets of flow file and then transfer from your source to destination. So that is what you need to consider. Like the major aspect in your Nifi is flow file based, and you will see this word coming across in a lot of our practice today and as we go along as well. This was a bit about Nifi. Next is like to see that where does it fit into our data ecosystem. Majorly, since it is an Apache suite, Apache Nifi, it has its place in big data ecosystem where it can handle a lot of volumes as well. And as I said, I mean, you can name it as a data orchestration tool or an ETL tool or a data ingestion tool because it does all these kind of work as part of the Nifi. you can build your data pipelines using Nifi. The major difference between your data pipeline and ETLs are in data pipeline, there may or may not have your transformation available. But in ETL, you have this ET, which is transformation available. So you can build using Nifi, the pipelines, data pipelines, the ETL process, the orchestration section, and the ingestion section as well. So this is where I think you can take Nifi and it can fit into all your requirements of transporting your data from one place to another, which is like a logistical requirement. And if you have any pre-processing requirement of your source information, you can do that as well in Nifi. So that's where it fit into the ecosystem very well on the data transportation from one layer to the other layer. Next is where we're going to look into the architecture of it. It's a very simple architecture, but it's very I would say robust enough to handle a lot of information. Since I said that Nifi is a web-based application, we would need a web server over here. And Nifi is written in Java, so it runs on a Java virtual machine on top of the operating system, and the web server is required to handle that web-based interface and all its API commands and all. So that's why the web layer sits at the top. The second layer is your flow controller. FC means flow controller, which contains all your processors and extensions. I'm going to show you what all these processors and extensions are. Probably I'll better to show you that as well. I hope everyone can see my screen, and this is basically a GUI of Nifi, which looks like the small boxes that you see inside. These are all processors that we call it as, and extensions are nothing but all these extensions like processors, the input port, the processor groups. We will see what all these are, but all these connections on tops and these are called as extensions. And these are processors. And this is your flow controller, which is also called as canvas in Nifi. And then since I said that it is based on Flowfile concept, the Flowfile management happens in these three repositories. These repositories are utmost important on Nifi. And as a data engineer, if you know the concepts of these repositories, what it holds, and what information that it provides, then I think majorly you can troubleshoot any of your technical issues that you find on Nifi. And we're going to see what these are. On the Flowfile repository, Flowfile is nothing but it contains the metadata of your current flows, and actual content of the data where you transport your data from source to destination. That actual content is stored in your content repository. So imagine when you have an HDFS, you have a driver and executor memory. The driver contains all the metadata, and executor is where you do all your work. That is something similar concept. You have it in Nifi as well, where flow file contains all the metadata informations of the flow file, which are currently in process, and the actual content of the flow file, which is data, is stored into your content repository. And the flow file metadata has a pointer to those content repository to understand that this flow file content is stored in this repository. Okay, so that's where content repository comes into the picture. By far of these three repositories, the biggest size is for content repository because of the actual reasons, because it stores the content. Hence, the size of this repository will be always higher. The third repository is nothing but your province repository, because it holds all your data lineage of the flow file. So the flow file, when it moves from one processor to another processor, and as it goes on, Nifi gives you that lineage information, that how the flow file is processing through, who is consuming it, and how and at which stage what changes are happening to that flow file. That lineage information is stored in this province repository. And these are the 5 major core components of Nifi. One is your flow file, processor, processor group, flow file controller, and the connections. Probably to understand these concepts, I'm going to move on to the application side of things, just to say that, whatever we just seen on the slide, how it looks like on the application side of things. And as I said, these are all your processors, which does the actual work. When we go back to this canvas, and this is your processor group. Processor group is nothing but where it encapsulate or groups all your processor into one hood. It's called as kind of, you can say it as a project. Like my project is Excel to CSV. I'm trying to convert an Excel file to a CSV, and I'm going to create a processor group. Inside the processor groups, I'm going to have all my processor. Processors are nothing but your actual piece which does all your backend work. It's a black box for us at the front, but these are all your connections which basically does your work at the backend. So these are processes and the processes groups. Then if you see these connections which are going from top to bottom, the success message, this is nothing but your connection, where once your processor flow files have been generated from top, it will then hand that processor to flow file to the below processor, and likewise your flow file travels from top to the bottom till here. Okay, that is where the flow file comes into the picture. And we talked about connections as well. And I'll just gonna start these processor just to show you how flow file gets generated. If you look at, there is one flow file got generated and it got stuck here. The reason it got stuck here because my flow file, the processor here is in stop state. You see this red signal. This is nothing but it symbolizes the state of the processor, whether it is stopped, whether it is on. So red signal means it is stopped. That means all your flow file will come here and get accumulated here. Okay. Likewise, the moment I start my processor, you will see that this symbol, this is something known as where your processor are in active state. These kind of symbols, active state, and it has processed as well. Now, if you look at the bottom, I have 4 flow files came into the picture. Now, what I did in my flow file is I have split up 11 records of Excel file into 3 records each, which means 4 files will get generated. One file will contain 3 records, and my 4th file will contains the 2 records, because 11 files. That is what this flow file comes into the picture. Now, put file processor is nothing but it will put into a destination which I want. Currently, I want that destination to be available in OPT NiFi MNT. Okay, so this is just a flow of what we have designed, how the flow file travels from top to the bottom, and what this flow file is all about. We will look into deeper of what these are, but just to show you what processors are, what a processor group is, and what is the connections, and and what how this flow file traverses from your source to the destination. Okay, now there are a lot of parameters that we need to configure that we will see as well. So now coming to the flow file repository and flow file content repository and province, I'll show you where does it reside on our server. So I'm going to log into my Docker image, where currently I am on my Docker terminal. So inside my container, this is my container for NiFi, and I'm gonna go back inside and open my terminal over here. This is my root path for NiFi, and inside that root path, you see this content repository, database repository, flow file repository, and province repository. This is where the actual information resides, and these repositories are helpful in flow management, flow file management actually. If you look at the size, I'll do ls-h. If you look at the size of your content repository is 20 KB, okay, which is by far the highest of all the others. Okay, other repository like content repository is 20K, your flow file repository is only 4K, your province repository is again 4K. Now the reason for having this content repository is 20K is because you have this flow file stuck here, and the actual content of this flow file is being stored in your content repository. Okay, now see if I delete this, empty this content repository. So I deleted your flow files, and now let's look at our size of our content repository. It will take some time to get refreshed. I think we'll come back to this and see whether it will delete it, but ideally this 20 KB will fall back to 4 KB again, where the content repository will get deleted because we have deleted the flow files from here. Okay. Since we have looked at the Nifi architecture and the components a bit in detail, we'll go on to the next slide. Now, this is a bit more about your flow file. What does it actually stores, how the management of the flow file happens inside, and how that this information is very helpful from a troubleshooting perspective. Okay. Now, ideally a flow file, what it contains is your metadata and a content claim. Okay. That is what we're gonna look into this. I'm gonna generate this again. Now, again, you have these 4 flow files. You're gonna look into these flow files. This is where you can list your flow files. Okay. And if you look at this I section, click on this, you see this flow file contains your flow file ID, your file name, what is the size of the flow file, and the content claim. Content claim is nothing but it contains the information about the content repository, where exactly it has stored. Okay. Inside the content repository, you will see a containers, and inside the containers, you will have this sections. Okay. Section 1, 2, 3, where exactly it is stored, and an offset to that content repository. Using this offset information, the container information, the section information, Flowfile understands that this is where the content information is stored in your content repository basically. And if you look at these, you can also view the content of your data. Okay, so the 11 records that we have created, out of which I have split it into 3 records, and these are the 3 records. So this is where it is allowing you to do the changes in live real time. Okay, ideally in any of the ETL tool, these kind of information or flexibility is not available. But if you're seeing what we are doing, we are on the fly changing your pipeline, we are on the fly trying to delete the information. You can even say like stop here, and you can then configure. Currently I said 3 records, and all of a sudden I can make it like 5 records. And when you run it again, you will only have like around 3 flow files generated. I'll delete this again. It has only generated 2 flow files because 5 records in each. Okay, so you got this flexibility of changing these things on the fly, real time, and web based. Okay, so this is one of the biggest advantage which Nifi gives you. Otherwise, if you look at your any other ETL tools, you may have to do this configurations at a lot of places, change certain properties, redeploy and do. But on Nifi, you did it on real time. You got this flexibility, and you can work on this. Okay, so this is the another advantage that we spoke about and that we have seen as well over here. Coming to the flow file thing, we have seen what metadata it stores, what the content claim is. Content claim contains all this information like container, in which section, in which, what is the identifier, offset, and size. And this content claim has a reference to your resource claim. This is an abstracted layer which we cannot see, but at the back end, this content claim has a reference to resource claim, which in turn has with access to these information, through which it understands that what kind of content is where the content is stored using this flow file information. So it's like a tracking of your content information via this flow file. That is how these information flows through. Okay, since flow file are actively being processed by the system, are held in JVM memory. Okay, now as I said, it's a Java based program. It runs on a virtual machine, Java virtual machines. Each and every flow file is captured inside your memory, Java heap memory, and it then processes efficiently. Now you can think about why it efficiently processes that many bigger information of data in the big data side of things, because Nifi captures all this flow file in its memory at a time in smaller batches. Okay, you can set this threshold in your Nifi application, where how many flow file you want to process at one go, so that it processes in batches and it gives that to another processor to process. Likewise, this cycle goes on and it starts from source to the destination one by one, one by one. Now, given its nature of repository is a write-ahead log. What do you mean by write-ahead log? Means it's always appends to your repository, which means it never overwrites its previous state. Whatever state it has gone through from, say, for example, it has come from fetch file state to convert Excel to CSV processor. Then these information is written back to your file repository. And when it comes from this information to the split record, it will again write it back to your repository. So it will keep a log of all this information. And tomorrow, for example, if your Nifi crashes out, you should be able to recover from that point itself and run it ahead because of this write ahead mechanism of flow file. Now you will say where I can see all this lineage information. We talked about province repository, which shows us the lineage. Now when you come to the top right corner, click here, you see this data province here. Click on this data province. These are all the information that you can see from a data lineage perspective. Okay, now let's click on this convert Excel to CSV processor and see what's happening here. Actually, the lineage will be, can you see this 3 settings button, show lineage? Click on here and it will see that, where that flow file has come. Now the red button indicates that this is the state of the end state of the flow file at this location, So this is the flow file at which red means this is the current location of that flow file. It has traversed from this area to this area. And when you look at these sections again, it will also show you where exactly in your flow you have designed it. So see, it has come back to this section. So this section of pre-processing of your flow file, like, forked, cloned, dropped, all this information has been captured in your lineage. So if somebody asks you whether your data has been processed correctly or whether it has reached your destination, Nifi gives you 100% delivery guarantee from your source to destination. It cannot drop off any information in between. That's the beauty of Nifi. And if somebody claims that, I didn't get these many records, which was there in source and destination, these lineage information will help you to trace back that, where it got stuck and how it got stuck. Okay. Now, some other information which I wanted to show is the relationship and the connection. Okay. Now, what you have seen is this is the success connection. What do you mean by success connection? Means if your processor processes your flow file successfully, you put that flow file to the downstream processor. That means that success then give this flow file to this processor now. Likewise, you can configure all your relationship like, what about if your processor fails? What you want to do? Currently, what I did is I have terminated that relationship, which means I am not expecting any failure. I don't want it to put any failure because these are not important ones. But imagine if I uncheck this, because currently it is stopped it. I will stop this and I will come back here, configure here relationship, and I will remove this and apply. Now you see there is an invalid processor symbol. It has come on here. Relationship failure is invalid because your relationship failure is not connected to any of the component. Okay, that means I will either have to terminate my connections or I need to give that connection to some other processor. These are the thumb rule as part of your connections. Okay, now if I say I will come here and I'll connect and I will say failure and add. See, it has come back again to red. which means all your connections has to either get connected to other processor or you terminate that processor, terminate that relationship basically. Now I don't want this failure to get connected here because there is no point. So I'll delete this. You can't directly delete because you need to stop your start and source and destination, and then the relationship can be deleted. Okay, so this is how I deleted. Now, again, I talked about if Nifi crashes, how you gonna recover it back. So this is the location where Nifi keeps it backup on your container on your Docker file. When we cd into this location, which is your root location of Nifi, and a config files, which is conf file. When we do ls-hell, you see this flowfile.xml.gz. Okay, this is nothing but what you have developed online on the UI. This, imagine your Nifi goes down. When you mean goes down, all your design and the processor design data flow which you have designed will also go down or will finish off. How you going to recover back? So what a general practice is, you keep a backup of this flow file somewhere periodically at whatever interval you want, or whenever you have developed some critical projects, you keep a backup of it, or you keep a backup of it on a regular basis of a weekly, monthly, or a daily, depending upon the criticality. Now, the moment you store this file and when you recover your Nifi services back on your server, on your standalone machine or on cluster, you put that file into this location again and you restart your Nifi services, you will look at these flow file back into your system. Okay, so whatever work that you have done, it will come back to your system again. Okay, so no work will be lost. All your hard work will be saved back again, just keeping a backup of this small file. Okay, so this is utmost important and very helpful when it comes to your. We have seen how we can recover back from a flow file because this is very important. Now imagine you want to share this uh, template with somebody else. Okay, now how are you going to do? So what we need to do is you need to just right click on it and say create template. Okay, and what happens is next time somebody wants to design something very similar or wants to customize this, they don't need to have build all this from scratch. All you need to do is come to here in the template section, drag and drop here, and then I have just created one template called as Excel to CSV. You click on it and add. See, all the processes came into existence again. Okay, so you're able to recreate it again with a very less effort. All you need to do, come back here and do the necessary configuration of your own and done it. Okay, so that's how you can reuse your work. Cool. That's what we have looked into. We have looked into what is your provenance repository. What does it give? It gives you the lineage. We looked into your content repository where it actually stores your content. And we have also looked into your flow file repository, which actually stores all your current flow files in the process. Okay. Now let's move on to something more. There is more to this flow file, but better I'll go ahead and do some practicals. And then if time permits, I'm then going to come back and show you how you can configure certain flow file parameters where you can actually resolve some of this issue. But one quick thing is when you right click this, where you can do this list and empty, you can also get this option of view configurations. In the view configurations, you can basically set the priority of your queue of how you can run it, whether you want to do it FIFO, first in, first out, first in, last out. Your priorities of the queues can be changed over here. Okay. Back pressure object threshold. This means if there are a lot of flow file to process by Nifi, then it can go down as well. You need to ensure that the flow file management is up to mark. And this is where you can do a back pressure object threshold of say default is 10,000, but you can increase to whatever configuration that you give it to your Nifi server, and basis on which it can handle that many flow file in conjunction during the live session. And or you can also give the sizes of that flow file. If it reaches 1 GB of size, then you apply a back pressure. Now, what is a back pressure means? What it does is, in the memory, it will keep maximum 10,000 flow file or 1 GB, and the rest of the flow file it will transfer back to your repository. When I say transfer back, that is where it will come back to this flow file. You see this flow file repository, it will go into this repository under a swap folder. You see this swap folder? This swap folder contains all the back pressure flow files, which is currently not being served by Nifi. What happens is Nifi will first give priority to this 10,000, process it, and then it swaps another batch of 10,000 from this folder and brings into the memory. That's how the memory utilization of the Nifi is optimum, and it should be able to handle a lot many flow files as it processes. Checkpoint is nothing but, as I said, it keeps all the information of the flow file from where it has started to where it has gone. And this is utmost important in case of failure, where you can start again using this checkpoint information. Okay, so this is all the major important information which I wanted to share from a repository perspective and the flow file perspective. We'll probably move on to the next slide over here. We have also covered the flow file section. We have seen how we can recover a flow file, what the flow file contains. We have seen the content of the flow file, how you can manage the flow file better, the memory of it and everything. Okay. Coming to the features of the Nifi, we have seen a lot of features now. That is what we're going to discuss here. Browser-based user interface. Yes, it is browser-based, and it gives us a seamless experience of design, which can be easily designed. Control, which you're able to control on the live. You can monitor things as well. Sorry. You can monitor using the data province as well, and you can feedback as well. I mean, in terms of feedback, where whatever you see, you can come back and rectify here. This is based on the logs that has been stored on the Nifi. Coming to the data province tracking, we have seen complete lineage of information from the data province section. That is where I think the data province, where we were able to see the lineage of the information. Then the extensive configuration. We have talked about Nifi guarantees us guaranteed delivery. That means no information from your source to the destination while you're processing Nifi will be lost. It has a very low latency. You have seen with a click of a button, we are able to process all your files, flow files from your source to destination in a very quick manner. Very high throughput, and you can also have a prioritized queuing. We have just seen you can also configure your flow file priority. You can set first in, first out, newest flow file processing first, oldest flow file processing first. That all you can configure in your connections by doing the view configuration. Runtime modification of flow file configuration. We have done that. We have shown you how we can delete the flow file on the file, modify your processor, and how that is possible. Data buffering and back pressure, where it can controls if your application has been flooded with lot of flow file at one go, you can apply this back pressure control by setting up some threshold on your number of flow files or the size of the flow file, basis on which it will apply your back pressure and push the upcoming flow files or the pending flow file processor into the swap folder of the flow file repository. So that is where features comes into the picture. Rapid development and iterative testing. We have seen that we can easily develop, we can easily reuse your components, we can easily configure with the click of a button, and you can also have component architecture for custom processes and services over here. From a security standpoint, we can't look much in details over here, but I can talk about it. Since it's a web-based interface, since your UI is HTTPS connection, we can attach an SSL certificate to your DNS name that you have, which ensures your data in transit is secure using that SSL certificate. Multi-tenant authorization. you can currently what we have is at Nifi, you can also integrate with Apache Suite, which is Apache Ranger, where you can give control to the user saying that they can look into these processes and that processes, where you are ensuring your authorization is into picture. You can also have this integration with any of your um, authentication mechanism in your company, could be LDAP, could be SSO, all that is feasible in your Nifi as well. Okay. So these are some of the features. We have also seen this feature in practical, and that's where I think Nifi looks quite beautiful. Now coming to the Docker installation, guys. This is what we will now look into, how you can build this on your local. Before you build this local, some of the prerequisites that we gonna require would be Docker. You need to have this Docker installation done on your laptop. If you look at this symbol, this is that boot symbol of Docker. Once you install your Docker, this Docker desktops comes onto your machine, which helps you to control your Docker images. You can SSH into your Docker containers and insert certain files of interest and all that stuff. Okay, so the primary requisite is to have this Docker installed on your laptop, which is again open source. You can easily install on your laptop with a Google search. You will get that download file and you can download this Docker. Now, once you download this Docker, what you next need to do is, I'm going to share all these commands as well with you guys, so you can go back and do that. Now, what you need to first do is you pull your Docker image from your public Docker repository, and this is that name of that Docker image, which is Apache Nifi latest. Okay, so once you do this Docker pull Apache Nifi latest, what you're gonna see is you will have this image on your local. I'm gonna do Docker images on my laptop. If you see this Apache Nifi, I have done a git Docker pull and it has come on my laptop, on my machine as a Nifi, Apache Nifi. There are certain tags which you can give. The current tag is for latest. This is your image ID, which we're gonna require as we go along. Once you have that Docker image on your local, where we have verified using Docker images, you're gonna do this Docker build -t Apache Nifi.latest. It will build your application first. And when you run this Docker run -name Nifi and port is 8443, the reason of having port 8443 is because of its HTTPS connection that we need, which needs to be secure. Now, as part of the documentation, when you look at, this is what they recommend to use as 8443 for HTTPS. If you want to use HTTP connection, well, you can go for port 80, 8888 or 8080. Okay. Once you fire these three commands on your laptop, you're gonna get this URL. You're gonna next put this URL, which is nothing but HTTPS localhost port 83 and Nifi login. Okay, I'm gonna come back here. Okay, but since I've already opened this one, I'm gonna remove this and I'm gonna come back to this session. I'm gonna log out of this section. So you have successfully logged out and you have come back. So I have added an authentication layer as well. When I say authentication layer, it comes as part of your Docker image authentication only. Once you do this, you will be able how to get the username and password. Okay, so when you do this Docker log Nifi grep, you should be able to get this username and password. You will have this application password somewhere stored in this section. Since it's, say this, username generated and password. This is the username and password which you can take on your local. Apply this username and password and you should be able to authenticate yourself. I'll use this username, I'll use this password. So you should be able to come back into your login. So you have authenticated your application on your local as well. There is one more references which I wanted to give you guys is Docker Hub Nifi. So this is the Apache Nifi Docker URL. You can follow along this. There are all the necessary commands that has been written here. That's what I have taken from here and showed you how it can be done. and pods running. You can also configure your custom username and password as well. So you can follow along these documents and run that. And that is where you can do this installation. The prerequisite for having this installation is to have your Docker, and you can then run all these commands on your Docker. Just a pull, build, run, and logs. With this, you will be able to get into your logger Nifi in your local. Now, one of the other very important thing is, now we talked about having your Docker as data source agnostic. But what do you mean by data source agnostic? Which means you should be able to have all your connectors here. Okay, since Apache Nifi gives you a base image, not necessary that all your connections of your source are available here. For example, I have typed Hive. This was not available at the Apache Nifi image, but this is what I wanted to have as part of my testing and environment where I wanted to use this Hive. So what we did is, the major thing that you need to do is all these connectors that you see, all this processor, it has certain softwares with it. Can you look at this libfile library? Whatever you see right now on the processor, these are all the nar files which enables you to look at those application processors at this. Okay, so what we need to do is we need to actually come back to the Maven websites. This is a Maven website where you will get all your processors nar files. Okay, say for example, you are looking to connect to a MongoDB. I have typed Mongo, you look at these. So there is a MongoDB nar file. You click on this and you can click which version of Nifi you have installed, and you can go back here and pull up that nar file and push that nar file to your Docker image container. Then you'll be able to see those MongoDB connectors in the processor. Okay. Now, since I have been using, I wanted to have Nifi. What we did is I went to Nifi, came to Nifi 3 nar file, and I have installed 1.19 Apache Nifi version. And from there, you see this big file of .nar. I have copied this file on my local, and what I then did is fired these Docker copy. So what I did is I have stored these nar files in my local folder, which is user Vinod and location and here, and I have given my Docker image ID. This image ID we have seen here, Docker images. See, this is the ID where you will get your Docker image, and you can get this Docker ID and you push to the location of your interest. Since I wanted to have these nar files at the library folder, I have done Docker copy from my local to the container, Nifi container, Docker container in my local. Okay. The moment you do this, okay, these files will be available here. Using same commands I have fired on my local as well, and it has come and pasted these files over here. Can you see this? Nifi, Hive. These were not available, which we have manually copied from my local to your Docker container via those Docker commands. Okay. Now what we then did is came back to the container, restarted this container, and it will then come back. Your UI will start again. You will log in again, and when you come back to this processor and type Hive, you will see all your Hive processors have come into picture. And then you can pull and create your profile. So this is what small design I have created. What I have did is, this is a Hive select QL. What I'm trying to do is I have created this in the properties. I have created a connection to my Hive where I have to give all my details, like this is the controller service where you will create all your JDBC connections, and this is where you will configure all your properties. My JDBC URL, my username and password, and a small validation query to validate my connection is correct, along with my authentication details. Once you set your controller service here, you call in you connect here and you provide a select statement. So this is a query that I wanted to run. Okay, pick query where I have taken, and what happens is I generate this, I create a connection, and this query gets submitted on my Apache Hive. Okay, and I was able to connect via this. So what I did, taken the base Nifi images, I wanted to connect that Nifi to Hive. I've taken the NAR files from the Maven websites. I have copied from my local to the Docker container. I have restarted my service, and I have just came back and dropped my processor, and I have typed, and I have all my connectors here. Okay, that is how you can connect to any of your data source of interest by pulling up the, now for example, MongoDB. See, delete Mongo, get Mongo, it already has these connections. So you don't have to bring those NAR file. But if you are looking out for some other stuff, where so now Kafka it also has as well. So wherever which is not possible, not available on your processors, you can pull this like this, and you should be able to do. So as a data engineer, you ensure that your hurdles you have resolved by pulling all these NAR files into the system, and your application is running, you are able to connect your data source of interest as well. Okay, so this was a typical demo that we had on the local file system that we wanted to show. I hope everyone, it was quite simple enough. You can follow along with all these documentations, and you can try it out on your local, and you can see how it goes. One other issue that you may get is, while you do this Docker build, this one, you may get an error. In case if you get an error, what you need to do is come back to this container. From this container, you can do a stop and start. Okay, once you do this, it will come into your running state, and then you can push this this command http localhost 8843 onto your browser, and it will start up. All these things are available on your references documentation which I've given you. You can just follow along those things. Okay, now since we have already burnt out, I'll take another 5 more minutes just to show you what industry architecture that we are trying to build in our company is. We have did this POC first on Hive, on my local first, tested how I can build all my NAR files and everything. So we are trying to achieve this kind of an architecture at our company, where what we are trying to do is we're gonna take that Docker image from the Docker Hub. We're gonna build our Docker image and push it to the ECR registry via the CI/CD pipeline of GitHub. The ECR registry is nothing but where you can register all your Docker images. Now, in order to CI/CD pipeline to push my Docker file from my GitHub to your ECR registry, I need to have some IAM roles which I need to consume, and it needs certain permissions so that it can log into your ECR registry, authenticate itself, and then post this Docker image onto your ECR registry. Okay. But on the contrary, if you want to do via console, what you can do is install this AWS CLI on your laptop, and via AWS CLI command as well, you can push this to your ECR registry. That is something which you can practice. Let's see if time permits, I'm going to show you that. But that is something which you can do from AWS CLI perspective as well. And you're going to push this to your ECR registry as well. Now, once you have this ECR registry, which means the Docker images which you are able to see in your local, that is something very local for an AWS. That means AWS cannot read directly from your Docker images. What we have done is brought that Docker images from the public repository to the AWS local, which is your ECR registry, where you can manage all your Docker containers. Okay. Now, from your ECR registry, you're going to create a AWS Fargate, which is nothing but a serverless compute services, where you can consume this Docker images and run on your on your website as well. Okay, so in that AWS Fargate, what you're going to have is you're going to have a ECS Fargate cluster, and inside that ECS Fargate cluster you can create a task definition, and that task definition going to have these containers on which your application will run. Okay, uh, this information can be a bit overwhelming, but this is always, you can go back, refer to this architecture and read more about this, so you will get a better understanding of all these services which I'm trying to talk about, and you'll be good. After the container, once it runs, what happens is your Docker is running, and then using that IP address, you can then make that application up and running on your browser. And since you cannot have that IP address, which is not that idle state to have, what we're going to do is we're going to create an elastic load balancer where users and to that elastic load balancer, we're going to attach your Route 53, where we're going to have a DNS name, custom DNS name for your application. And to that DNS name, the users will hit that DNS name. Okay. Now, DNS name is nothing but whatever you're trying to hit. Just localhost is as good as one DNS name too is, and we're going to have a custom DNS name so that everyone can use that DNS name on your browser and access the Nifi application. Okay, so one application which I'm going to show you is what it's already running at my end on the AWS stuff is. I'm going to show you that quickly. Meanwhile, it's up. So this already up and running. Currently, I think it has been down, but I think it was probably up. It will be up and running on this IP addresses. I'll just quickly take you through the ECR registry. I'll try to quickly run through all these things on the AWS side of things so that you are aware. So what we can do is on the ECR side of things, you can create this repository. Okay. Once you have this repository, inside a repository, say for example, I have been using this Hive test demo, and you can register these Docker images. Let's try and push one Docker image here. So I have set my AWS CLI to the account in which I want to access, and I've just already set up some of my code. So this is an AWS CLI command where I'm gonna do a authentication to my ECR repository. See, you have registered and logged in successfully to your ECR registry, and I'll do a got Docker image, and I'm gonna take this hello world and try to push into our ECR registry, and I'm gonna name it as hello world. Okay, so before you push, you need to tag your image. This is what the tagging is all about. We are seeing this tag. That is what we're gonna tag there, and we're gonna take those tag over here under this URI, and I'm gonna push this Docker image. So it says your Docker image is already exist, and it still goes ahead and updates if required. And if you look at these, see 10th February, hello world, and this is where you are able to push your Docker image on your ECR, which means now you can play around with this Docker image in your AWS local, and this Docker image you can then consume in your ECS container. Okay, let's quickly go through that as well. So what we're going to do is we need to create one cluster over here. Create cluster doesn't have much steps, only networking only. Since we're going to use Fargate, you need to choose networking only option, and then just do a create over here. Just give a custom name what you want, and that's it. This is how you will create your cluster. And to this cluster, you're going to add resources later on. So this is one of the cluster which I've created. Under here, I'm going to create my task definition. Okay, say for example, I'm going to use my Fargate option. I'll do a next. I'm going to just put some random name. Then you need a task role. That's what we have looked into our architecture. This is what the task role is looked about. The small hat of IAM role is nothing but your task role. You're going to select your task role. When you're doing for the first time, it will automatically generate. Since I've already created it, this role has been created. Now this role is required basically whatever your ACS required access to, like an S3 bucket or a EFS file system or any service it communicates to, it will have the necessary permissions in this task role. The network mode should be default, should be okay. Operating system, we need a Linux box, same task role. You can have a, say, I've given 8 vCPUs, and you should have a 1:8 ratio, means one CPU should minimum have 8 GB of RAM. So since I have chosen, say, 8 vCPUs, I'll say 8 into 8, which is 64 GB memory. Okay, that's how it should be enabled. Sorry, 8:16, it's what it's called about. Then you can add your containers. In the container, you can give your container name, and here you have created your digit. So you need to take your image URI, which means you're going to consume this image in your ECS, okay, cluster, and put this image over here. And you can keep all the rest of the port mapping. We said 8443. Okay, then we can keep all the health checks, environmental as it is, network settings, storage as well, default resource. And then we're gonna add, and you can add this volumes. Now, since here I don't have permissions to attach EFS, but this is where you can attach a volume over here. The volume is nothing but this EFS volume which I'm talking about. Okay, now once you create this, you will have this task definition created. Okay, now these task definitions, here you will have number of revisions. Now imagine we have built these many revisions of your task definition by doing some trial error. This is our dev environment, that's why we are trying to do this one. So in this task definition, this is where you can go back and check all the JSON files and everything. Okay, nothing, you can validate that. And once you have this task definition created, you will go into your cluster, come back to your Nifi cluster, and you will have this service. You can create this service. Okay, and here you will have this task attached. See, this task is running at the moment, and it will have all the IP addresses of interest. So this is the private IP on which you can check whether it is running or not. Okay, I think my VPN must be blocking, but let's see whether it starts or not. But otherwise, I think this is where you can try to create these services on the Nifi cluster. On the cluster, create your task definition, and inside the task, inside the cluster, you can have your services created. Create service, and in these services you can choose your Fargate, and then here all the other detail like Nifi, your task definition, which task you want to choose, which revision you want to choose here, the cluster name, service name you can give of your choice. Number of tasks, we need only one task right now over here. And now I'll choose one VPC, I'll choose a subnet and everything, or to assign. Here you can check this network load balancer, application load balancer. This is what I was talking about, ELB and others. And you can assign here, and then you can just go back and create this one. Okay, so you can check this, do not adjust the server design, because since you don't want auto scaling here, we are happy to move with server no auto scaling option, and it will just create that services, and it will review and it will create. Okay, so that's how I think we can basically build this. I know it was a bit rushing because of the time constraint, but it would needed a bit more time. But nevertheless, we tried to cover as much as possible. We were able to push your AWS CLI, from your AWS CLI, the Docker images to your ECR registry. From ECR registry, we were able to create your Fargate where we can give the URI of your Docker images. Then from there on, you can create your task definition and services. And when you create your task, then once your task is up and running, you can take your private IP address and try to hit your application. Your application should be up and running. The other side of things, which EFS, Route 53, Elastic Load Balancer, these are more from a security standpoints, which you can add, especially your load balancer and Route 53, because your IP address will keep on changing as and when your task will stop and restart. Okay, so hence your elastic load balancer will encapsulate that changes, and whatever IP address changes, elastic load balancer will not affected, and that will ensure that your DNS is always up and running with your credentials what you have given. Okay, so this is a bit on your serverless architecture. These are all the few documentations which will help you in terms of a deeper understanding of your Nifi Apache, Apache Nifi, the in-depth process of this links, the Docker image link, the Maven repositories where you can take the NAR files. And this is another Cloudera documentation which has explained all the components of Nifi in detail, which is a must read if you are interested in these kind of in working on Apache Nifi. So go through these references; it will be very much helpful. In terms of Q&A, I'll be happy to take few of the Q&A. An alternate option is your Airflow. Now, AWS also has a managed Airflow service, but you also have a Docker image for Airflow as well. So something very similar like how we have built using Nifi Docker image, you can build using Airflow as well. The alternative to Nifi is Airflow. Okay, so that is something which you can build. Okay. Now, what are the advantage and disadvantage of using this application? I think we have seen a lot of these advantages on this over here, because it will help us. It's a real-time application where you were able to change a lot of things on the fly. It was web-based, no coding requirement and all. On the disadvantage side, side, troubleshooting can be a bit issue. The logging of these application is not that robust, so sometimes you may get into trouble of how to resolve these issues and all that stuff. The configurations can be a bit tricky as well, but as you go along with all these documentations and others, it should be good. Somebody has said that I'm studying BTech. How can I learn it from where documentation? Or I think I have shown you all the practical aspect of it, of how you can learn these things and all. And documentation, it's part of my references where you can go back and take that documentation. Those are absolutely amazing documentations. It's very well explained in those documentations. It's self-explanatory. And in case if anybody wants to work on these kind of things, you always have my LinkedIn profile. You can connect with me. Happy to catch up and look into this. Okay. Somebody said that Apache Nifi available for free, or does one have to buy? No licenses to buy Apache Nifi. What we have built right now is an open source, and it is freely available for us to practice on our laptops, and you can use it anytime. Okay. Data orchestration means the way you want to process your data one after the other. Normally what happens is, say for example, you want to achieve certain task, you will write 4 to 5 SQL statements. Just an example I'm saying, say SQL1 completes, then SQL2 completes, then SQL3 completes, and then your entire task will get complete. Now what will happen in Nifi is you can orchestrate these flows. Orchestration means nothing but, okay, awesome. So this is where we have. So what we have done over here, this is nothing but an orchestration. Orchestration means you have triggered the flow file, then it has come to select HiQL and then to log. This is nothing but what you have orchestrated your flow. Okay, something very similar we have done in Excel CSV. This is how you orchestrated your flow, orchestrated on from fetch file to the Excel to CSV converter, split records. So this is nothing but an orchestration is what you meant about. Now somebody asked about relationship between Apache NiFi and Apache OpenWhisk. I'm not too sure about what is OpenWhisk is, so I cannot comment much on that side of things. But in terms of the similarities, you can always have Apache NiFi closed with Apache Airflow as well. Airflow is something very similar where you can do these kind of things, but that is not that intuitive to use, because that is not a GUI based. That is more like a DAG based, when you need to write a code in Python and then orchestrate your flow. But from an ease perspective, Apache NiFi is much better compared to Airflow. I think most of the questions. Can we get the documentation for NiFi setup on cloud? No, it's not available. Cloud infrastructure is something you can build of your own choice. You can have your own design. It all depends what kind of a requirement you have, what kind of a security that you want to implement, what is the file system that you want to implement, whether you want to persist your data of your flow files and everything or not. So based on that, you will pick and choose the services. So there is nothing specific documentation available, but it's up to you how you want to design based on your requirement. Okay, so that's good. So
Thanks a lot, sir, on the behalf of Analytics Vidhya. I would like to thank
yes.
you for all your time and delivering such a wonderful. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future.
Thanks, guys. Thanks for having me. It was great experience. Happy to share all my knowledge over here. Do connect with me on LinkedIn if you want any more details around it.